Yep. Thank you, Jonathan. Uh, Let me quickly turn on my camera first. Hello, everyone. I'm Asmit Ghimire, and I'm currently working at Gurzu as a software engineer. And it's been a while. I've been working in Ruby. And as I started my developer journey, I was initially working with PHP and Laravel, basically, and also like some front end stuff with Vue.js and React.js as well. And for now, I'm totally focused on Ruby. And yeah, so first of all, I'd like to thank you for giving me this opportunity to join in this talk session, this whole Ruby meetup. I haven't been associated or taken part previously in any such events, so that's a pleasure for me. And thank you everyone for joining this event. So I'd like to share my screen here. I'll be stopping my video and sharing my screen now. Is my screen visible? Can someone confirm?
Yes.
Okay, so what I'm going to talk about today would be the scalable system and common problems. So basically, how I want to portray this is what I faced while when it came to scaling and the problems that I faced. So that would be the whole uh, uh, presentation would be based on the experience that I had and the things that I went through. And I hope that anything that I present here would help someone in any way that it can. So what does scalability mean for systems and services? So scalability means a system that can handle rapid changes to workloads and also the growing user demands. So a system for it to be scalable would have to like accommodate rapid changes to user behaviors and demands, and also like a rapid increase in the user bases as well. So accommodating all that would make a system to be a scalable one. Uh, so let's talk about a premature scaling before moving into the whole scaling thing, because premature scaling is a problem, and I've seen companies like burn down and collapse basically when they like try to scale prematurely. So why does it happen? And I like to like go through it, a little overview over it, even not a deep dive onto it, just an overview. So premature scaling happens when startups try to scale up too early, and it can like kill a company with unplanned budgeting as well. So a proper way to and the steps to scale would be like discover your product, identify the product market fit, then validate it, find a repeatable sales model so that like you can like scale, basically like pass on to the newbies whoever joined the company, and like flow, make a good flow so that the repeatable sales model can be followed and the product can grow in that way, and then only like focus into the scaling, fill the funnels and grow the business. So the basic step would be get ready to grow, and but avoid premature scaling. So what most of the company do is they try to like strengthen their product before like trying and like researching about what the proper and good market fit would be for the product. And that's when like the number of increment in the teams, or the number of or the like higher budget investment in the marketing, digital marketing, would like basically burn down the company, and like it would be a very difficult for them to like grow in terms of user bases and growing user demands. So I'd like to talk about the problems faced in a scaling system. So this would be entirely based on my experiences. So I'd like to like first of all go through all these points, and I'd be talking about them one by one in the upcoming slides. So the first, I'll go through the first one. So the issues encountered as of my experiences were insufficient system infrastructure. So it's basically like your server resources are not sufficient when it comes to large user bases and growing user bases. And the other issues would be like heavily dependent on the application itself and the infrastructure and the way the app is designed. So those would include N+1 queries, memory leak and bloating, bulky and slow APIs, and also missing DB indexes. So I'd like to talk about these items today. So server scaling. So how do you go about server scaling, and what are the ways that you can scale up with? So there are two ways you can go about server scaling. One would be the vertical scaling, and the other would be the horizontal scaling. Uh, so you have also the figure there comparing the two ways about going with the scaling. I like to talk about both of them one by one. So the first one would be the vertical scaling. So vertical scaling basically means increasing the capability of a single server. So you'd be only bumping up a server that you're already using. It's a pretty instant way to scale, and also appropriate for a growing system who is just going into scaling and not that big of a, not reached to the peak in terms of like user basis or growth of the user basis. So the pros of vertical scaling would be easy to implement and maintain, and also cost effective. So if cost is the factor that would matter to you, vertical scaling would be the one that you would want to go with, as it would cost less and also easy to maintain and implement. The cons would be it would be a single point of failure. So if you are trying to like build a robust infrastructure, yeah, vertical scaling might not be the ideal one to go with, as it would be a single point of failure and there would be no other instances to take up your application once any kind of like server crashes or spikes or anything that could lead to crashes. And also hardware limitations is there in terms of the cons for vertical scaling, because you could only bump the system up to a certain point where the hardware is limited. So that would be the other cons that would have while vertically scaling. So the next one would be horizontal scaling. So horizontal scaling basically means adding more of the same instances of resources. In this scaling pattern, you would have workload distributed by load balancers to the number of instances that you have defined. It could be any number that you have defined. It depends on basically the user bases and how you want to like grow the infrastructure. So it is also appropriate for a large system. The larger system go with horizontal scaling rather than vertical scaling because it is more robust. It can handle more user bases. And the pros would be those. One would be more fault tolerance and fewer risks of downtime. Since we have load balancer and multiple instances, the workload can be distributed to the healthier instances and not the one that is not unhealthy. So it can also scale well with increasing demands. So you can always add new instances and always grow your infrastructure if if the need is so. But the cons would be the architecture, whole architecture would be a little bit complex because you would have a layer in between to be able to like scale, because a load balancer is required for horizontal scaling in terms of division and distribution of the load the server gets, and it is also a little expensive and a complex compared to vertical scaling. So I'd also like to talk a little about load balancing. So load balancing is associated with horizontal scaling, and it is a layer that sits between clients and the servers in terms of simplification. And the load balancing distributes incoming traffic across multiple sources, multiple servers, sorry, which you can like also visualize in the picture that I've put in here. So the goals of the load balancing would be maximize the resource utilization. So basically you would be throwing the request to the healthiest resources, which would like maximize the resources that you have and not like overload the resources that is already spiked or unhealthy. So which would like also give us the minimized response time and also maximize the throughput because all of the requests would be distributed and the whole response time and the throughput would increase. Response time would decrease and the throughput would increase. So most of the popular load balancers are Nginx, ELB, elastic load balancing, it's a proxy and load balancers.org. There are also a bunch of out there, but yeah, these are some of the popular ones. I'll also like throw in links to these resources so that you can yourself go into and look into the load balancing and all stuff, because I'm not talking about a lot on this one. So I'd like to talk about the n+1 query problem now. So this would be the one thing that would bother you for sure in terms of scaling. And this was also one hectic or a complex thing that we had encountered when we were into scaling. So I'd like to talk about a little about what n+1 query problem is. I'm sure like most of you already know about this one. I just want to present it in terms of our Ruby code so as to you can understand clearly if you happen to not have a good idea about it. So here's an example with Rails that I put in. So let's say we have a post model which belongs to a user. So as you can see in this code, post.all.h, basically it's grabbing all the posts that's available in the DB and looping it through and like printing out the post's the username which was posted by user. So basically every post would be associated with a user. So what it's doing is it's like putting one query to get all the posts, and it's looping through each post to get the username, which would be like querying the database every time you like loop into those posts. So in the above example, it first retrieves all the post objects and then user for each post. So if there are 10 posts in the database, then you would have like 10 plus 1 queries executed to have the username of all the posts. So in the next slide, I want to talk about how to solve the n+1 problem with eager loading. So with eager loading, a query loads the resources as soon as the code is executed. And there's a way you can do it in Rails as well. So there's a method called includes available to eager load resources. And let's see how the includes helps to eliminate basically the n+1 query that the problem that we had in the previous example. So what has been done over here is post.includes user has been thrown in there, which is basically trying to like eager load the user for all the posts that we want to grab from the database. So here, user for all posts are preloaded in the memory, which omits the additional DB calls to each to fetch each user's names. So this is simply how we get rid of n+1 issues in particularly the Rails applications. So that would be how you fix an issue that you see in certain like endpoints or any methods or anything that you have encountered with. But also when your code base is a little larger and you have like a couple of unoptimized queries thrown everywhere, it would be a little hard to like tail down each and every n+1 query problems manually. So you can there's a tool called Bullet Gem. It's a library that's available for Rails, which you can integrate into your gem file, and you can basically automate n+1 tracing. How it works is it actively monitors the queries that are run in the console in the Rails application while it's in the real time, and it basically logs the recorded issue in this way. So the tracing example is also shown in here. So it says use eager loading detected, post is missing comments as an eager load resources, and so that you can add to your query.includes comments, which would basically resolve the n+1 query that you have in this particular example. So this would be an example of how you use a Bullet gem and integrate into your application to basically find out each and every issues that you have regarding n+1 issues in your application. So I want to also talk about memory leaks also bloating. So there are two ways that you can have memory issues in your Rails application. So one would be the bloating, which would be the sudden increase in memory consumption, while memory leak would be more of a slow and gradual increase in memory uses. So what I personally had encountered in my experience was a memory bloat, which was basically high object allocations being done in certain endpoints, which was basically bloating the memory instantly and occupying whole memory resources that's available in the resources, and eventually like crashing down the server as the memory has been all occupied. So that was one thing I went through, and I also want to talk about how I went into like configuring and like finding out the issues that are spread across the application. So look at memory leak and bloat with application performance monitoring. So there are application performance monitoring tools which would like help you track errors and monitor applications with insights on CPU and memory uses. So some of the popular APM tools are New Relic and Datadogs. There are also many tools available for APM. I've personally been using New Relic for now, and there's like an example of a chart that New Relic provides, which like gives you an idea of the response time, the CPU utilization, throughput by host, and memory uses. So you can like figure out when the memory has spiked or when the CPU has been spiking, and you can also go through the log for that certain period of time to get into the issues and track down what is causing those issues. I'll also want to talk more about the other tool, which is skylight.io. So for memory profiling, I'd basically prefer more Skylight over APMs, because this is a smart Rails smart profiler for Ruby and Rails applications, which can aid in pinpointing problem endpoints. So this is an example of a dashboard that Skylight.io has. So you can see the problem response, typical response and request per minute, and the graph for each individual metrics, and also the endpoints. So what Skylight does is it basically lists all the endpoints that your application has. I've only linked two in here in terms of example. So that whole API endpoints listing would have certain kinds of mark over there. As you can already see, there's a DB mark, which is basically high object allocations being shown over there if you hover into it into the actual dashboard. So it helps look at APIs with slow responses, high object allocations, and N+1 queries as well. They all have their own symbols, which is like marked into each endpoints, and you can like basically track down which endpoint is having which issues. So what I did was I could like look at high object allocation endpoints through the Skylight.io, which was basically having the memory bloating issue in the applications. So it has been a very intuitive and helpful tool for me, and I really recommend everyone who's not used to this to give it a shot. And the other issue I want to talk about is the bulky APIs and basically the slower APIs. So the bulky APIs are those which in which we try to like load many resources in a single request. So which would be a problem in terms of quick response cycle and a good user experience, and also server resources. So basically, when you have like bulkier APIs, the server resources would get more heat and more consumption in terms of memory or CPU utilization. And the Snappy APIs would always benefit over the bulk APIs in terms of response cycle, user experience, and distributed server load. So this was also another issue that we had in our experience while like in terms of scaling. So we'd have to like segregate some APIs and introduce some newer versions of those APIs in terms of less object allocation, and like in terms of reducing the server load, and also like improving on the response cycle throughput and the overall user experience while engaging in the application. So in conclusion, we faced multiple issues in our experience while scaling the Rails applications, and we were able to make following improvements with the presented solutions that I came up with. So there was around 146% increment in the throughput of the overall application endpoints, and the response time was decreased by 190% in an average. The average memory consumption was brought down to around 2.5 gigabyte from around 8 gigabytes. So that was another issue, heavy issue that we had in terms of scaling. And we also got rid of CPU spikes and server crashes with these optimizations that we made. Thank you. That would be it for my session. If you have any question, please feel free to ask.